Okay, so now let's continue with the second part, which is going to be starting with some harder questions. So there will be 10 questions in this section, and we are starting from question number, I don't know, let's just not talk about the question numbers anymore. Well, it says that we have a little bit of a number puzzle on the right-hand side, and it's asking you what digit does the triangle represent? Yeah? So in these kinds of number puzzle questions, it's very important for you to determine which type of analysis are you going to use. So we have three different shapes, the circle, the square, and the triangle. Now we can see that it's an addition puzzle. So two of these two-digit numbers adds up to a three-digit number. So what does it mean? It means that, well, whenever we have two-digit numbers added up, and it gives you a three-digit number, the hundredth place of the three-digit number must be 1. If you don't believe me, you can try any combinations of two-digit numbers you like, and you can find that any two-digit numbers can just make a maximum sum of a three-digit number in the hundreds, all right? So now we know that the circle is representing the 1, so we can replace all the circles with 1s. Now we have something more than 10, adding another two-digit number, and it is giving us 110 and something, right? So you can see that in the tens place, I have the circle adding the square is equal to the circle, which means that in the tens place, when I'm adding the circle and the square with any possible carryovers, it gives us 11. It gives us 11, which means that there is definitely a carryover because the maximum sum that one can make with another digit is going to be 10 together with a 9, right? So now it tells us that the square is going to be 9, because otherwise, if the square is any smaller than 9, then even with a carryover, which is like the maximum is going to be 1, it can never make 11 in the hundreds place and the tens place of the sum. So now we know that the square is 9. And finally, we can just add up the two 9s to see that, well, the triangle is representing 8 because two 9s makes 18. So that's what the triangle represents. Okay. And the next question, now we are looking at a multiplication puzzle here. It's a multiplication puzzle. So in multiplication puzzles, well, of course, we still need to determine which types of analysis we're going to use. So we are multiplying a 5-digit number to 4 in order to get another 5-digit number. So let's think about L and D right here, because like these two are definitely the breakthrough points. Just think about if you're multiplying a 5-digit number by 4 and you still get a 5-digit number, the first 5-digit number that you're multiplying by 4 can't be too big, right? For example, if I have 50,000 multiplied by 4, that's going to be 200,000, which is a 6-digit number already. So after a little bit of trial and errors, we can see that L must either be 1 or 2. So it can't be any greater than 2. Okay, and now let's just look at the last digit right here, which is also L, because you can see that lift, all written in the other direction, is devil. So the product ends with an L, which means that it cannot be 1, because anything multiplied to 4 should be an even number. So L must be 2. Now let's think about what is big enough, or like what multiplies to 4 gives you a product which ends with a 2. So now we have two candidates for D, which are going to be 3 or 8, because we know 3 times 4 is 12 that ends with a 2. 8 times 4 it's 32 that ends with a 2 as well. But can D be 3 if you're just looking at the D in the 10,000th place of the product? No, because 2 multiplying 4 is already 8, and it cannot be smaller than that. It cannot be smaller than that, right? Otherwise, the calculation would not be correct. So it means that this is leaving us with only one option, that D is going to be 8. So yep, that's how we get the answer for D. And of course, if you're interested in trying the remaining digits, feel free to do so, but the question is just asking you what D is, so you can definitely stop just right there. All right. And next, we are moving on to some new definition questions. So you can see that in this question, you are defined with the notation of an exclamation mark, which is also known as factorials, if you have heard of it before. But it doesn't really matter. It just means that if I have a number with an exclamation mark behind it, it essentially means multiplying starting from that number all the smaller integers smaller than or equal to that number. All right, and it's the product of that. So if you want to work out what is 76 exclamation mark over 74 exclamation mark, that's just going to be written as 76 times 75 times 74 times 73 all the way till 4, 3, 2, 1. Over 74 times 73 times 72 times 71 all the way to 4, 3, 2, and 1. So we know that for a fraction, if you're just having some multiplications in the numerator and some multiplications in the denominator, they are all considered the factors of the numerator and the denominator, right? And we also know that we can simplify a fraction to its equivalent fractions by dividing the numerator and the denominator by the same number, which means that starting from 74, all these smaller numbers can be simplified. All these smaller numbers can be simplified until finally the whole denominator is simplified and we only have 76 times 75 left in the numerator. So the answer is 76 times 75, which again we can make use of the multiplication pairs such that 76 becomes 19 times 4, where 75 becomes 25 times 3. So using the associative law, we can write 4 times 25 as 100 first. So we have 19 times 100 times 3, that is going to be 57 hundredths. All right, so that's the answer to this question. And the next one is also defining some new operations. So here it says that a triangle B, or a delta B if you want to pronounce it like that, is equal to 3 times of A adding B. So here we have an equation which is related to this operation. Of course, we know that we cannot just try to solve this equation with the new operation in that. So we need to express this equation in some normal calculation first before we solve it. So first of all, let's try to express 6 delta x, or 6 triangle x. And that's equal to 3 times 6 adding x, which is 18 adding x. All right, now we can see that outside the brackets, we have 5 triangle that. So 5 triangle in brackets, 18 adding x, is equal to 3 times 5, of course, adding whatever is inside the brackets, because that's like the whole lot of that is counted as B, or the part after the triangle. So adding 18 adding x, that's what we have. So we have 15 adding 18 adding x, and that is going to be 33 adding x. And we can see that on the right hand side of this equation we have 40. So we can now write 33 adding x is equal to 40, which naturally means that x is 7, because 7 adding 33 is 40. So x is equal to 7. All right. Now, the next one is an arithmetic progression question. So we can see that in this number sequence, each term has a difference of 4, right? But then, unlike many other questions, you can see that this calculation is like this arithmetic progression is going down. But it doesn't really matter. Even if it is going down, of course, we know that we can write it the other way around, right? So why don't we just write them like 10, 14, all the way up to 74, 78, 82, 86. Of course, that would be fine. And then we can just try to find the number of terms in the sequence. So the number of terms can be calculated by the last term, 86, take away the first term, 10, divided by the common difference, 4, and adding 1, or any other ways you like. So that's going to be 76 divided by 4, that's 19. 19 adding 1, that's 20. So we know that in this sequence we have 20 terms. We have 20 terms. Okay? And then, after knowing the number of terms, we can just try to pair these numbers up, because we know that each pair of them is going to have the same sum, right? So the sum is equal to the first term, 10, adding the last term, 86, multiplying the number of terms, 20, and remember, divide by 2, because you're finding the number of pairs altogether. So that's going to be 90 times 20, 96 times 20 divided by 2, which is 960 as the answer. Okay. And then the next one is still about arithmetic progressions. It says that the sum of 15 consecutive even numbers is 330, and it is asking you the sum of the next 15 consecutive numbers. So it didn't mention even right here, but then this question is a little bit ambiguous, so we have to count everyone correct in this question. But I'm just going to show you how to actually get the literal answer for this question. All right. So first of all, you need to know the median principle for the arithmetic progression, which is if you know the median or the middle number of any arithmetic progressions, and you can just multiply the median by the number of terms to get the total. So now we can see that there are 15 numbers and the total is 330. And we definitely know that the median is going to be the middle term, right? So the middle number of 15 numbers is going to be the 8th number. So we can say that the 8th number is equal to 330 divided by 15. Of course, that's the inverse calculation to find the median, and that's going to be 22. So after knowing the 8th number, are you able to find the 15th number? Of course. We can see that it's a chain of consecutive even numbers, which means that each two of them has a difference of 2. So there are 7 common differences between the 8th number and the 15th number. So the 15th number is going to be 22, adding 2 times 7, because that's 7 more common differences, and each common difference is 2. So that would be 36. All right, so for the next 15 consecutive numbers, the sum should be equal to 37, adding 38, adding 39, and all the way up until there's 15 of them. So, well, you can do it in many ways. It's either that you can just try to find the last number of the sequence, or you can also try to find the 8th number of the sequence, such that multiplying by the number of terms, that's 15. 15 numbers, that's what I should write. So if you find the median of the second arithmetic progression, and you multiply that by 15, you also get a sum. So that's what I'm going to do. So like the 8th term, we know that 7 common differences more, right? So each common difference is 1 this time. So it means that it is 7 more than the first number, and that's going to be 44. So after knowing the median, 44, I'm just able to calculate the sum by the median multiplying the number of terms, and that is going to be 660. So that is going to be the actual answer of this question, all right? But don't worry, we have counted everyone right here. And the next part is about the magic squares. So for the magic squares, the rules is that the sum of each row, each column, and each of the 2 diagonals is going to be the same. So, for example, it means that let's name this box X, all right? So it means that in this column, we have a sum X adding 9 adding 11. And in this row, we have a sum X adding 3 adding M. And these 2 sums are going to be the same according to the rule of the magic square. So naturally, I can just remove the X from both sides of the equation such that it will not affect our result. And now I have 20 is equal to 3 adding M, which naturally means that M is going to be 20 take away 3, that's 17. So M is 17. All right? And there's another thing special about the magic squares, which is the middle number, the middle box, is always half the sum of, like the 2 other boxes, like the 2 opposite boxes divided by 2. All right, so probably I'll just rephrase that again to help you understand it. So for example, if I have any 2 opposite boxes, either like these 2 or those 2 or like the diagonal 2, any of 2 opposite boxes, the sum is going to be double of the median or the middle number. So the middle number is always half of the sum of any 2 opposite numbers. So now in this magic square, the only pair of opposite numbers we can spot is 11 and 7, which means that I can find the middle box by adding them up and halving it. So naturally that's going to be 18 divided by 2, which is 9. So I have 9 in the middle. Now I want to find the value of A. So apparently there are many ways I can do it. The first way is just to find the sum in each row, column, and diagonal. So that's going to be 11 adding 9 adding 7, which is 27. And now I can use the sum 27 to find the top box. So 27 take away 17, take away 9, that's going to be 1. And finally, using this row, I can find A. So A is just equal to 27, take away 11, take away 1. And that's going to be 15. All right? So that's the answer to this magic square question. All right, we don't have much questions left, I believe. It says that 73917A is a 6-digit number with different digits, and it is a multiple of 25. So this is kind of a question related to the divisibility rules. So if you think about all the multiples of 25, they must only end with 4 possibilities: 00, 25, 50, or 75. Any other 2 digits will not be a multiple of 25. So like any other numbers with any other digits, like ending in any other digits, will not be a multiple of 25. So we can see that the second last number here is a 7, which means that the last number must be a 5. All right, that's kind of easy. And, well, let's take a look at the last question we have. So it says that P67Q8 is a 5-digit number, and it is a multiple of 36, where P and Q are both digits. Now, what is the largest possible value of this 5-digit number? So first of all, we haven't learnt about the divisibility of 36 yet, but we know that 36 is 4 times 9, which means that any multiples of 36 should also satisfy the divisibility rules of 4 and the divisibility rules of 9. And in other words, whatever satisfies the divisibility rules of 4 and 9 will also be a multiple of 36. So right now we can see that, well, if it needs to satisfy the divisibility rule of 4, then the digit Q must be 2 or 6. It must be 2 or 6, right? So let's just mark it down right there, 2 or 6. Because the divisibility rule of 4 is that the last 2 digits should be able to be it's more than 2 or 6 actually. It can be 2, 4, 6, 8, 0. So basically any even numbers. All right, so even number. Because according to the divisibility rule of 4, it means that the last 2 digits should be divisible by 4, right? So Q must be an even number such that, well, the 2 numbers are divisible by, the 2 digits are divisible by 4. All right, so let's look at P now. So, well, we want this to be as large as possible, right? So probably the largest digit I can think of is going to be a 9. So let's try 9 for P. So now we have 967Q8, where Q needs to be an even number. Now let's try to think about the divisibility rule of 9 and where we can apply it. So basically, in order for a number to be divisible by 9, all the digits must add up to a multiple of 9. So now we have 6, 7, 8, and 9, which adds up to 30. The next multiple of 9 is going to be 36, right? So we can see that the difference between 30 and 36 is 6. Which means that if I want this number, this 5-digit number, to be a multiple of 9, I need 6 more in the digits, where 6 happens to be an even number. So now we know that Q is equal to 6, and the largest possible value of this 5-digit number is 96768. All right, so that's the answer to the last question. Well, if you have any questions, feel free to let us know and we will try our best to help. Thank you.